I guess, from the technology wise. Okay, here we're gonna talk about our OR3 Universal PowerShell Input Connector. We discussed about this, in the last in a global summit and all, but this is mainly about getting more in details about the differences. So, as you all know that this is Natesh. Right now I'm an engineering manager for Asia Pacific for Positronic Industries. I've been in this company for 16 years. Um, been Today we're going to talk about the mainly is the scope overview. It just give the more broader for all the audience know what happened in the past, how we started this project, and there's a technical challenges before the global summit, and product introduction, because this is a joint development with with as a group we developed this, and just give a little bit about the introduction, and then the technical challenges after the global summit. Okay, so which is like the connector variation and some of the key enhancement we did after the global summit, and finally the project timeline and when it's going to be available, and everything will be ready, and just go with that. Okay, just a scope overview. I'm not going to detail about everything here about all these fine details. So as we know that the open rack, the V1 also, we've been our connector has been selected, and then V2 also connector has been selected. I personally involved on the all these, especially the V2, and then so the V3 actually. So if you look at it's keep on increasing the power requirement, or the capacity of the connector we have to push to the max. So we have selected, we are using the size 8 contact, and some of the numbers we can, it's on the spec, but it's just to compare the V1, V2, and V3, how the connector has been evolved from the 3-pin version to this 7-pin version right now. Yeah, here is the technical challenges before the global summit. I think maybe a year ago or something, one of the thing engineering workshop, and then we met in a Facebook office, the whole joint, the committee, the group. We come up with this all the scope and finalize the thing. So it was the challenge. Try to fix, try to fit the connector in a space, in a very limited space, or the scope is very tight. So the limited space was the first challenge we need to achieve, and then the higher amperage, as we have seen in the previous slide, it's been keep on increasing, and it's same as the voltage as well. And another thing was, it was when V2 was designed, it was just the male side is a PCB, and the female side is the crimp. And we've been discussing a lot about how can we have some modularity, and then some adaptability wise, how can we make this the V3 connector more flexible. And the other big topic was the power efficiency. And I think some of you know that the power efficiency is very important in the data centers. So we have to choose the connector and the materials, the technology within the connector itself to have a more power efficiency, and then the minimum number of parts on in terms of to handle everybody. So that was the challenge before we have a global summit. And then we achieved almost everything, and then we presented our connector and we made a sample. So after that, we the product we use, for to design this for the V3 is our Scorpion Series concept. Okay, so how this connector has been designed, as it's a modular connector for the V3. These are all the different accessories and different type of mounting options available, and the contacts has been the models has been designed as a what we call a individual model, which is cable. We can have a cable version, or a straight PCB, or right angle PCB, or any type of things we can design within this these modules. So what we call these as the end modules, with the left and right end modules, and this is contact modules in the middle. So after this, like I said, after that we made a sample and we hear from the feedback from the engineers around the world, and the the request was to have more. So within that space, we need to have a different variation, and who knows, maybe this could be expanded to the V4. So those some of the key points after after the global summit we heard was the connector variations. People want to have more variations, like different style of terminations and all they need, not just the mail is a the PCB mount, and then female is a crimp only. So they need a more flexibility in that. So another thing was the connector polarization on the PCB and the panel, because later you can see we have two connectors, so on the single rack, so which is left and right connector. So we need to have proper polarization in the panel as well as on the PCBs, just to make sure things are assembled in properly. And the more cable size variation, this is another request came in, and then the flexible cable exit for the hood. We had when we designed this, because as you know that the connector is left and right connector. The same connector for the female is been using for left and right. The male is a two different connector, but the female is a single connector. So the flexible cable exit for the hood was another request. So then let's see one by one the wiring configuration. So as I told just now, I mentioned about uh, more requests came in. So initially we had in the spec for the connector with the 12 AWG version for the car wires, and then we added a 10, and then we added 8. So to have more, if somebody want to use it to the max level of the connector design. And this is the wiring configuration. Actually, I took this from our spec to have some of the three phase five wire install connection, or in a three wire connection, single phase, or so some of the configuration we have included in the spec. um, so let's take a look at this the rack where this connector. So our connector is the input connector is located here, as I just mentioned about the two connectors, and this is left and right connector. So it is as you know, as you look at this view, it's the space is very constrained, so we need to come up with a way to design the connector as slim as possible so that it can move around, and you can know that the back of the rack there's not much space, and that is another challenge. So let's look at the left and right connector in a differentiation wise. So this is the right connector, and this is the left connector. And as you can see, the polarization is for the right connector, it's on here, and the left is here. So it's basically we develop in a way, in a manufacturing method. We did this by what we call inverted bending. So the plastic is same, the insulator is same, but we had a different style of bending so that the connector can be installed. The same connector, the same insulator can be used for two different connector. And then other differentiation we talk about is so we had an identification on this left and right connector. This was not before the global summit, but after the global summit. As you can see, the L stands for it. The L is we engraved this L and R for the left and right connector. And I will talk about this pointer kind of arrow or triangle, whatever you call, in coming slides. So these two we added, and then what else we did is I just mentioned about the polarization. So this was the another big change we improved from the previous the prototype that we made. We added this profile more visible and bigger, and then so that the connector has been installed properly onto the panel. So with this in the panel cutout, we added this feature as well to for this polarization. But if you look at this, there is same thing will goes into on the PCB also. So The PCB also, the connector, need to be polarized properly so that it won't be mixed up. So these two we added from the prototype before the summit. So if you look at this, I just mentioned about this arrow. So the R, and you can see the R on whatever the right connector is. If you look at this arrow, actually this indicates the pin the pin position numbering. So the numbering starts from, if the arrows is like this, the numbering starts from left to right this way, and then the arrow is this direction, and it just starts from right to left like this way, this direction. So we have a clear indication for male and left and right connector. This we added as well for this after the summit. Um, another big thing was the cable exit. The cable exit is a very big challenge for us because of the size restriction. I just show in the back, the back of the rack, we have a very limited space, and this was the spec we came up with as the JDA. We came up with this is the limit that we can go, and 65 was the max. So, and this is 23.8 was the max. So we have to design everything within this given spec, and be able to squeeze it, and then be able to achieve this. And if you look at this cable exit for the left and right connector, the cable exit from what you call a 45-degree exit. So the cable exit from the connector in 45 degree this angle, and the request was to have more, to have a more flexible cable exit. That means we can have a 45 degree, and it's also we have a top opening, so it means comes right out of the rack. So some might have that also needed in that. And another thing we did change was that it was 18.6 in the prototype version, and we actually had increased it the opening to 23 millimeter to the max. So if you can see the spec, we're still within the spec, the dimension limit we have. So this the previous version was here on the left with the soft tooling. What we did is a 45 degree cable exit, and this is a 45 degree still exist, and this is a new one we added with the new opening. Um, and if you look at the left and right connector, and again this is how it looks like, the cable exit, and this is a top opening. I just mentioned this is a 45 degree exit, and this is a top opening. And the way we designed the hood, we redesigned the hood completely. So we make the hood also modular. That means you can have more option. So what is how this modular is going to achieve, and this portion of the hood is from the fixed insert, and this is the interchangeable insert, which is on the injection molding side. We did this design because so how we make it more flexible. So that means we can have a different variation. Not only this, at the moment we have these two exit, but if there is more needed, which means if somebody has more space or they can have more flexibility, you can have more different variations or something to the hood for the especially for the cable exit. So this is a big change from the design aspect as well, because we did not include it at the time for the modularity of the hood. So this is the key thing we had changed after the summit. And another request was the polarization for the hood. If you notice it, because we have polarized, because we trying to use the minimum skews. That you remember, that's one of the challenge. We try to use the minimum skew, so we don't want to create more parts, to complicate the thing. So we try to use as minimum as possible. So the way to use it, we had more polarized things, so make sure we won't mix up, and then try to use the same component. So the hood, the wire exiting, let's say this way, you cannot install, the polarization is added to the hood and then connector. So if you look at the hood, there is a polarization same way for the both also. So the hood top, what we call hood top, because it's two pieces, right? So the top and then bottom, you cannot, you cannot assemble in a wrongly. So we make sure we assemble the hood in a proper way, so that we can achieve what actually, the thing of getting it into the sims. Okay, if you look at the again the variation, so this is we added this as well after the feedback. If you look at the connector variations, I can mention, you can have more, a stripe PCB for the male side with panel mount, and which is a right angle. This is actually the current connector that we've been supplying. But these insulator, again, like I mentioned, the insulator is common for the PCB, and this is a crimp version for the male connector panel mount, crimp version, and this is what do you call a hybrid? Crimp and then PCB together. And look at the timeline. um, this we started this as a joint development, as for I would like to highlight this. If you look at this latch, this was actually, it's amphenol design, and it's amphenol and positronic together. We've been uh, providing this as a solution. If you look at in the spec, an amphenol port number also there, and positronic port number also there. So it's not any proprietary. So, but we are collaborating it together to offer best solution. So this positive locking feature will give a more easy handling purpose as well. So we signed this in the 2019, and then we kicked off and we did the prototype. And I like to thank Artisan, Delta, and Light On this kind of people. They really give some very input, like a Harry and his team, and then in Anthony and team in Delta in Taiwan. So it was very useful, and then we able to make it more so more perfect connector. And we begin the tooling. The tooling is going on right now, and the first article inspection is going on. And this quarter, by I think by December, you can have these samples, more samples from the actual production tooling. So we are trying to hit on the Q1 of 2021 with all this the testing and validation and UL qualification and other type of qualification, and then we can submit for the committee adoption. And trying to release in a full production mode in Q2. So I'm not running out of time. Okay. So that was this is my last slide. We can have like I said, this is a joint development connector. Anybody can, please, if you are have something, please give his input and join the group. It's a very exciting group with a lot of individual talented people there. So the information is there on this link for the spec, and other drawings and everything will be available. And that's my last slide. So any questions? Try to be fast.
Thank you, Natesh. Great presentation. First of all, I'd like to congratulate you and other people contributing to this connector. I saw this morning today throughout the day, two other power shelves other than OpenWrite V3, and they were, to my understanding, they were both using this connector. So
yep, it sure did look like it, right?
Yeah, it looked like the same thing. Yeah, so it seems like this connector has an impact, is actually penetrate the industry. Very glad to see that.
Yeah, right. A lot of people has been asking that, so that's a good it's a good news. I mean, thanks for sharing that.
Yeah, I see a couple of questions. I think this one you answered it. Are new version samples already available? You said, I guess, Q4. Which is
yes, by December the samples will be available for production.
Okay. The last day of Q4.
No, last day of Q4, so okay, definitely
last month of Q4.
It's like a Christmas gift before the Christmas. Okay,
we can get it as a Christmas gift. All right. The other question I have here is the Positronics connector 32 amps as per spec, or 50 amp as shown on your presentation?
Okay, the 32 amps is per our OCP spec. we have given. That's what I would recommend. But the connector that what we are using is the size 8 contact with the, we are using a high conductivity material. If you use a 8 gauge wire, with the 8 gauge wire with the terbium copper contact, you can reach 50 amps. You can easily get 50 amps.
Is it a different pin or?
It's the same pin, but right now, remember the initial samples and all, we've been using the 12 gauge wire, especially, even the Facebook and all. And if you go in with the 8 gauge wire with the same material, because we adapted as a common, like you said, to not try to have so many components. So we use the high conductivity contact as a standard material.
I see.
So you can have
The
50 amps.
The pins is capable. Is a matter of fitting the cable, gauge 8, inside.
Correct.
Oh,
Yes.
I see.
But
All right.
you remember in our initial meeting during the scope refinement, we even want to have more than 50 amps, like 55 or 60 amps. Somebody is asking, and we said the possibility of going with the bigger wire, like 6 gauge wire. There is some UL recommend for that. So we wanted to keep that as a maybe the next connector development, the next stage of adding that 6 gauge option to push more than 50 amps.
Yeah.
So it's still possible.
Okay, got it. Yeah, I know that, we are based on latest spec, OCP spec is 32 amps. But I know you can make it more if you want with the 50 amps with the higher gauge wire.
That's a good question. Yeah.
Yeah, I don't see
Catch.
any other question on the Fantech website. Any question on the Zoom? Any guys having any question on the Zoom?
I don't see anything. Caleb, have you seen anything?
Nope, I do not.
There are no questions. I'd like to make a quick mention here. There is a table per UL, the G7 ADV, which has some limitations on wires, and that may be a problem for some users. The point about multi-conductor cable assemblies, gauge 6 wire is limited at 45 amps, and it would require some kind of deviation in terms of the allocation of ampacity on the wire if a user would like to go up to 50 amps, which is technically feasible within the temperature range spectrum, but the UL limitation will apply. So keep that in mind, guys. The connector can go way over 50 amps, even 52.5 amps at good temperature rise with the correct material on the contact. So the connector is not the limitation, it will be always the cable.
All right. Thank you for sharing that. So I guess Caleb and Steve, we are at the end of the presentation today. I think we have a very good round of presentation shared today, very technical information shared. I'm really happy that we had that good information exchange today. What do you guys think?
Yeah, absolutely. It was thanks to everybody that contributed today, and a lot of people that stuck around in the rooms and out in the community that were here. So it was really good. A lot of good information throughout the whole day.
Yeah, I personally want to thank Steve, Hamid, and Caleb. You guys are so kind. All the time you've been helping this during the development, which is really appreciated, and I really thank and appreciate you guys for that.
Yeah, sure. Thank you as well.
Appreciate your support.
Yes.
So I'd just like to say thanks real quick to both Caleb and Hamid for hosting today. You guys did a great job. So appreciate all your hard work today. So thanks a lot.
Thank you, Steve, as well for
Yep.
supporting throughout this process and getting here